Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to all of you, ladies and gentlemen. First of all, I would like to say thank you very much for watching this video. This is actually a very short discussion that we are going to focus on case control data analysis procedure, especially if you want to run data analysis to make conclusions with regard to the odds ratio and also logistic regressions. Okay, before we begin, let us have a look into our objective. So basically, our objective of the study is we want to explore, is there any relationship between a certain independent variables with a certain dependent variables in this case. Okay, so without further ado, let us dive into our data. And then we have a look into the data analysis part. Okay, all right, so let me share my screen for a while. All right, so this is the data that we already set in the previous video. So I already shared with you and explained in my previous discussion about this data. And then we have also the group here, and also other independent variables. For example, this one is age, followed by gender, and so on. So in the first thing, in terms of data analysis for the case control, you have to find out is there any significantly different in terms of grouping, especially if you want to eliminate or creating some sort of stratification procedure in the mental hazard statistics, especially if you're talking into public health or epidemiological approach. So to begin understand about all these things, generally speaking, if you conduct any case control study, your DV will be your case or control. So that is purely your dependent variables or the outcome that you are trying to investigate the relationship with. All right. So the first step, if you conduct any approach in terms of data analysis technique for case control study, make sure you familiar with the first thing, we call it as the DV. Okay, so the DV of the case control study probably will be not similar like the ordinal data analysis technique. All right. So that is the first insight or the first idea about this approach. So the first thing that you have to do is actually make sure that you don't have a missing data and so on. And then you have to run for chi-square. All right. So I'm going to use the syntax. So the first step, I'm going to run the chi-square to make a judgment in terms of comparing different demographic factors with DV, which is either cases or control. If there is a significant difference, therefore that particular demographic factor probably become one of the major factor or major indicator that will be controlled for the next bivariate and also multivariate analysis. All right, so let us familiar with the coding. So we got two groups, cases 1, and then control will be number 2. So it is important to understand that if you run the odds ratio, you must make sure that your group is being arranged in the according of the epidemiological design. Let me share with you the idea using the Excel. So basically, we have here as a case, and then we have here as a control, or we have here as a ill and also not ill, and then we have here exposed, and then we have here non-exposed. So that is the design of conducting any odds ratio calculations. So that's why you have to code it as 1 and 2, and then this one also as 1 and 2, or with regard to your independent variables that you are trying to investigate. Okay, so the first of all, I'm going to run for the cross-tab, chi-square. It's about cross-tab. So the groups should be inserted inside the column over here. And then I'm going to insert almost everything. Okay, I'm just going to insert everything inside this variable box except for the numerical data, because the numerical data are not suitable to be used, especially for the chi-square analysis. And then run for the statistical chi-square, and then run for the nominal data analysis. So actually, this is a second step. So because the first step, you have to run for the descriptive statistics to explore your data in terms of the tabulations of your respondent and so on. But I'm going to skip that one because of the interest of time, but I will run it after this anyway. So this is the first step that you have to do. You have to run for the chi-square analysis. So the chi-square analysis is very important, especially if you want to understand is there any significant difference in terms of the independent variables. So we have a lot of independent variables over here, and also by our group. So our group is actually DV, is either cases or control, and I'm going to hit the run button over here. So I may want to rerun it again. So you can just highlight everything, this syntax, and then you can just click Control R or Command R in your Macintosh, and then you can generate this outcome. So this outcome is very useful for us to make interpretations. So there are some warning around here. If you can see, no measures of association are computed for the cross-tabulation gender and also group, at least one variable in each group. Okay, because the gender, majority of the gender is actually male. So this study is particularly talking about male populations. Okay, so that's why they cannot compute it in according to the good manner. So let us have a look into one by one. So this one also is not complete actually. So I have to modify my coding again because I made a very simple mistakes, which is I did not request for the percentage or the proportions. So I'm going to repeat again, analyze, descriptive, and then proceed with the cross tab. And then insert your DV, which is in this case or control, inside the column, and then put all your rows, your factors. So I'm going to remove the gender because all of my respondent is male. The statistical data analysis indicated here as a chi-square, contingency, pi, and Cramer's V. And in fact, you can also run for the risk analysis to obtain the OR, the odds ratio. So the odds ratio will be used for the case control study in terms of making interpretations based on the odds. So you must remember the null of the odds will be 1. So if the odds is actually more than 1, it is suggesting there is excess risk or possible factors that may influence the occurrence of the disease or conditions. However, because a lot of my data is actually not 2 by 2 tables, therefore I may not want to click this button. Okay. And then I can proceed with the cells. Just now I forgot to click for the column to generate the proportion basis for the data. Therefore, I'm going to rerun it again and then paste it accordingly. After I paste it inside my syntax, then the output are going to be generated like this, and I can highlight everything and then press Ctrl R or the green button over there to generate the output. So the output is actually being generated, and then the indications here shows that the n is actually 240, where I got at least I would say 100 cases and then 140 as known cases, or we call it as a control group. So the first factor is actually locality. So this is most important thing to look into, whether there is a significant difference or not. So there is no significant difference in terms of locality. By using the chi-square, actually we can justify that the proportions for this case and control is actually well distributed. That's mean the locality is not a major factor in terms of the statistical manner. However, the researcher have the opportunity to run by the basis of certain localities that they suspected to be a problematic area. But in my analysis over here, I can suggest that there is no significant difference because of the asymptotic significance, showing that the value is actually more than 0.05. Therefore, we fail to reject the null hypothesis, and we might want to conclude there is no significant difference in terms of the proportions, because the null for this hypothesis testing will be the proportions of the cases and control are similar. So that is our null. And our alternative will be the proportions of the case and control are not similar. And therefore, based on this, we can say that we fail to reject the null, and we make a conclusion. The proportions of the case and control between different localities actually similar. So that's mean there is no difference. So this is not a major factors that we might want to control or further investigate in our further analysis. Similarly, goes to the educations. And then we can also investigate about the occupations group. So the occupation group also suggests that the value of the total expected count less than 5 is actually more than 0%, but less than 20%. So that means we still can use our Pearson chi-square. However, the asymptotic significant difference showing that the value of the P is more than alpha, and we might want to fail to reject our null. That means our null is remain there. So what is our null? So our null will be the proportions of the case and control according to the different characteristics of the occupations is similar. That is our null. So what is our alternative? The case and control, or the distributions of the cases and control is not similar in terms of the different occupation status. But this thing is very clear. It is also not a factor. Ethnicity is not able to be computed. So ethnicity probably can be removed from your data analysis approach, because it is not relevant, because everything is talking about the same. So ethnicity is actually A6. So I may want to update my code over here, the syntax. So just remove like that. So that we know already after this, if you rerun this syntax using your own data set, then you can also imagine that data analysis. So similarly also goes to your addiction type, and then followed by the addiction quantity based on the different positions of these perceptions. Okay, so this one we find out that there is something to do with the values over here. If you can see, this one, the p-value is more than 0.05, fail to reject null hypothesis, and we can conclude there is no significant difference, or there is no significant associations in terms of the cases and control group between the addictions type. And then after that, we look into the addiction quantity in terms of the perceptions toward those quantity, whether none, mild, moderate, or heavy. We can find out that the levels of the chi-square over here is one cell expected count less than 5, which is graded 12.5%. The rule of thumb to use the Pearson chi-square, you must make sure that the expected count less than 5, this one, is actually less than 20%. In this case, we met that conditions, and therefore we can use the Pearson chi-square. And our Pearson chi-square indicated that the value is 16.440, and our asymptotic significance will be less than 0.05. Therefore, we reject the null hypothesis. So in this case, we can sort of note it somewhere. I'm going to use the notepad over here. Sorry, I'm just going to use the Microsoft Word over here to just note it that one of the factor or variable is already significantly differ. So that's mean it is need to be further investigate in terms of these factors that probably may influence something with regard to the cases or control conditions of our patients or output that you are trying to investigate, right? So I'm going to just put over here addiction quantity. So addiction quantity is actually in our A8. So I may want to put some notations here. A8 is actually your addiction quantity, but this one is actually perceptions. Okay, perception. But this one you must remember. This is one of the factor that may influence the occurrence of your output, which is either IV or DV. Which is influence your output in terms of cases or control. So that is the first one, addiction quantity. And then you can go to the type of cancer over here. So the type of cancer, you can see a majority of the data show a very high level of Pearson chi-square value. And then we find out that the expected count is 5 also. It is not more than 20%. And therefore, we probably want to use the Pearson chi-square over here because the asymptotic significance also show that the levels of significance is less than 0.05. However, if you can see here, we got an error in terms of the type of cancer. Okay, so I may want to look back into type of cancer. So we have here as a bladder cancer, and then I'm not sure why there is some sort of zero over here or missing values over here. So probably I have to look back my data for the case and control. So if I go to the type of cancer over here, I can see that the number is always 1. What about the control over here? And then the control also actually talk about education quantity. Oh, okay. There is no indications about the issues of the things. Okay. All right. So let me have a look. Okay, we got until P, and then this one also should go until P. Oh, okay. I got already the idea. Right. So we have something to be adjusted accordingly here. Because our data have slightly different in terms of the arrangement of the data lah. However, if you can see, this one also can be neglected lah because of the cancer type is recorded all of the cancer risk. Okay, so the next one is GSTT1 group. GSTT1 group talking about present or null conditions also shows significant difference. So this one need to be investigated in the future. So you can just put here. The next one is GSTT1. GSTT1 is actually your variables in terms of the A11. Okay, so I'm going to put here as A11, GSTT1 factor. So just put inside a bracket so that we know that this is the variables that we are talking about. And then GSTM1 also shows significant association. So GSTM1, if I'm not mistaken, is A12. Okay, so you just put here as A12 GSTM1. It's actually indicated that this is the variables involved. And then GSTP1 is actually no significant different, or there is no significant associations. Therefore, we can say that the GSTP1 is not the factors that you can focus on. Okay, GSTP1. So what about the A14 over here? So the A14, the XPD. So the XPD also show there is no significant association. And then the last but not least is actually XRCC also show there is no significant association. Okay, so to be truth, there are only 3 parameters show the indicator using the chi-square about this arrangement of the data might influence something for you to be considered running the another models. Okay, so the chi-square actually helping you in terms of understanding what kind of factors that you want to control. So in this case, we can see that this is the element of control that you probably want to take into account when you run any logistic regression, A8, A11s, and also A12, because they are showing some sort of differences. Okay, so these differences also showing that they might contribute significantly towards the outcome of your investigation process. Therefore, we have to be careful with this A8, A11, and A12. All right, so the next models or the next approach that we probably want to investigate more is actually running for the logistic regression, looking into the risk factors that are related to our outcome. So to do that, actually, you can just go to analyze regression and then proceed with the binary logistics. However, this one cannot be done. The reason of this thing, probably because of your outcome here, the group is not being coded as 0 and 1. So it's not easy for you to justify using the SPSS. So to make your life easier, or to make your computational element much more easier to be understand, maybe you want to change the number 2 into number 0, so it's become 1 and 0. Means that we are investigating the cases, so we make the cases as one of the major computational element for the algorithm SPSS by putting 0 as control and 1 as cases. So to do that, we can just recode into different variables. So the way to do this, because we don't want to disturb the conditions of the original data. And then we can just specify number 1 become number 1, okay, add, and then number 2 become 0. So that's mean this is our control. And then you can proceed with the paste button over here. After you paste it, and then your data are going to be arranged accordingly inside your syntax. And then you can run your syntax, just run it so that we know already a new variables are being created here is actually DV. So these DV are going to be used in our logistic regression model. So analyze regressions, binary logistics. So this binary logistic, you have to insert your DV inside here as a dependent variables, and followed by all of the factors except for the A8, A11, and A12, because this one need to be controlled later on. So to do it in the robust manner, or in the I mean in the non-conditional in the non-control environment, or a non-influential environment. So probably you want to insert everything except for A8 and also A11 and A12. So this is a basis of generating the odd ratio to make sure that the computer is actually producing the model for you. So you can also specify the models by clicking the next button and insert those variables that possibly may influence your data by inserting these things. So this is how you want to control your data. So your data are actually being running off all of the factors, including excluding this another additional variables, and then you insert another additional variable. So that is one of the idea, to do it in the hierarchical way. Or another way to do that is actually you insert for the block 1 for all of the data without control environment, and then the next idea is actually you run everything with the control condition. So this is the hierarchical way, and then this is a robust way. So the robust way, you run this one first, and then you can rerun again with your inclusions of the A8, A11, and also A12. So to do that, I'm going to save the syntax, right? So the syntax are going to be copied and then inserted those A8, A11, and A12. Why I'm going to use this A8, A11, A12? Because this one is possibly the most control conditions that we need to be considered to ensure that our data are running smoothly and also giving accurate interpretations and also output. All right, so the next step, we have to go to categorical data over here and then specify your categorical data. So as default, all of the data here are going to be indicate as the final condition as your reference. Means that, for example, your A2, okay, so because your A2 is not appropriate variables to be inserted because it's only one, there is no variation, right? So you might want to exclude that one. Similarly, goes to the type of cancer, which is the A10, because it is only bladder cancer in the first place. So I'm just going to leave it like this, and then go to the categorical again, and then insert those variables as follows. Okay, so the A3 is actually talking about locality. So the last locality, if you're not mistaken, is FATA. Okay, if you forgot about it, then you can refer back to your data set. Okay, let me just recap back what is my last group over here. So for the locality, the last group, is a FATA. So that's mean the FATA are going to be a reference point. Okay, that's why in the journal articles publications, they insert that one as a, we call it as reference, or 1.0, means that that one is a reference point for a specific outcome that you are trying to be tabulated your outcome after the SPSS run for you. So you can request for CI, and then usually these two items are going to be considered to be click or check classification plots, and also Homer's Lemma goodness of fit, because these two statistical approach aim or helping you in terms of finding the models fit, whether your logistic regressions are fitting the models, or your logistic regressions are not fitting the models. Therefore, I'm going to click the paste button over there, And then automatically the syntax are going to be produced over here. And then this is, I'm going to call it as a crude. Okay, this is a crude odd, which is we do not include any additional data set due to the fact that this data set are not included with the adjusted one. So the next one is actually adjusted odd ratio. So in the adjusted odd ratio, you might want to consider to insert another additional variables that already show some sort of significant association just now. It's A8, A11s, and last but not least, A12. So you can just highlight everything into your primarily main outcome over there. So just highlight it and then go for the run conditions over here, or click the green button, and then the output are going to be produced for you. So to understand the logistic regression, you must understand that logistic regression will be produced in terms of two kind of hypothetical judgment. The first one, the SPSS are going to predict the models based on the block zero, means that there's nothing happened to this group. And then it is also important for you to understand that the levels of the block zero here, especially in terms of the percentage correctness, must be higher after you deploy the block one. So this is a block zero. Okay, this is the block one. So the block one method indicate that all of the omnibus test model of coefficient show not significant. Okay, so this is talking about the model fits. You have to look into your statistical book to understand this one. And then the model summary are one of the most important things, because the Nagrekel R square is actually a pseudo R. Okay, so Cox and Snell, Nagrekel, and these two actually are usually being used, but debatedly being argued among researchers because of the use of it in terms of giving some sort of understanding. So based on Nagrekel R square, we can find out that it's about 13, or I call it as a 13%. Not variant as explained, but actually the probability estimate based on the iteration method for these probable issues. Therefore, we can see that it is actually not very high. But this is pseudo R. It just give you, okay, all of this is actually predicting 13% in terms of occurrence of 0 and 1. So osmolar measure, we expect the significant level actually to be more than 0.05. So in this case, it's more than 0.05. So we're glad because it is showing some sort of fitness over there. And then we have a contingency table for osmolar measure. As I mentioned to you, osmolar measure help you to justify based on your group of 0 and 1, which is your control and cases, the arrangement in terms of this data. You see the observed count is 6, and then what we get here. Right, so by the time you run the analysis, you can see how accurate it is, and then you can see also the classification on the block one is not significantly, I would say, is improving from 58 point something into 66 point something. Okay, so the next step is actually looking for the variable in the equation. So this is the very important story that you have to report in your data set. So one of the important things is actually looking for the exponential B. So the exponential B will give you suggestions in terms of the odd ratio count, and then whether it is significant or not is already being specified over here. So you can see there is no significance in terms of the locality of each of the positions that we compare with. So each of these output or this outcome actually need to be reflected with our condition of reference. So our reference, which is FATA. So that's mean locality 1 compared with FATA. Locality 2 compared with another district, and so on. Okay, so your exponential B is actually your OR. So the exponential B is actually your OR. And then this is your 95 CI, looking for any significant, significant relationships or not based on your variables. So based on this, we can see that a lot of exponential B is more than 1, which may suggest the excess of risk, or this is the risky area or risky condition. However, you must remember that it is not significant. Okay, it is not significant. And then you can see here is educations, and then suddenly there are education 1, 2, 3, and 4. So actually this is the control, and then or reference, and then this is the statistical analysis being produced by the SPSS. Similarly with the occupations, we can see here we try to justify, is there any significant? Oh, there is no significant. All right, so for the addiction type over here, we can see also there is no significant. For the GSTP, we can see that also there is no significance. So this is actually observed group variable and predicted probabilities based on 0 and 5. So more towards 1 is actually successful predicted, and then less than um, 0.5, for example, in this left side, it is actually suggests that it is by chance happening in terms of 50-50 basis, means that it might be happening or it might not be happening because of the positions of the predicted probability group is at 0.5. And then we can also find out that there is no significant relationship in terms of our OR and also our outcome. Okay, but remember this one is a robust manner, not including those control variables. So if you want to insert your control variables inside your models, so maybe you can just add this one. You can see here A8, A11, A12 is actually additional variables that we inserted to control our crude oil to see whether there is a different or it is actually a similar positions in terms of their data being tabulated. So we can see almost the same classification tables indicate 58.2 seems like similar with the previous output. But remember, this is beginning block 0. It is a hypothesis null. Okay, this is very interesting. We can see that the omnibus test showing significant model fit, and then we can see that the model summary also is improved from 0.1 just now, 0.13 if I'm not mistaken. It's become 0.27, which is just 27% of the uncountable variables that may influence something in terms of your outcome. And then you can see that the host molecular show also indicated the values of more than 0.05, which is just it is a model fit justification over here. And then the classification tables also improve. Before this is actually 68, if I'm not mistaken. So if you forgot, you can rerun it again. And then this is very interesting part where we try to find out is there any significant relationship between variables. So you can see here the JSTT and JSTM is one of the significant variables that may influence the outcome of your study. Similarly with the XPD group 2, so XPD, you have to look back what is your XPD. You see XPD is actually looking for the 0, 1 and 2. So our reference is actually based on the GLN over the GLN. So in this data or in this outcome, we can see that there is a significant relationship with the XPD2. XPD2 is actually the because you arrange your data is 0, 1, 2. So that means your 0 will be this one, XPD, your 0 will be LS, LYS, LYS, and then your group 1, sorry, this is your group 1, this is your group 2. So the group 2 is actually talking about LYS over the GLN. Okay, OLS over the GLN on the basis of our control variable is actually GLN over GLN. So when you look into your model over here in terms of the output given, especially for the exponential B, it's very important for you to find out what is the risk element that being associated with our data. So in this case, we can see one of the element is talking about the significantly related, which is XPD2. Okay, XPD2 is actually these variables. Okay, XPD2 is actually this variable LYS over the GLN. And then similarly goes to the GST addiction quantity, because the addiction quantity is one of the numerical data. So this is very interesting because you find out that the p-value is actually less than 0.05, and therefore there is a significant relationship between the outcome and also these variables. But it is actually a negative position, because you can see the coefficients over here indicated that there is a negative influence based on the probit of your data. So 0.562 minus means that you increase this one, something will be decreased on the another part of that. So 0.03, okay, and then the R, the OR is actually less than 1. So our null is 1, means that nothing happened, but it's actually less than 1. Probably is suggested by epidemiologists as protective factors. Okay, but JSTT, if you can see over here, is 2.61. It's actually more than 1. It is excess risk that showing some sort of significant influence for the JSTT1. So JSTT1, if I'm not mistaken, over here is actually only present or null. So the condition of JSTM1 is important in terms of predicting the outcome of your cases and control. So JSTM1, it is less than 0.05. There is a significant relationship, or there is significant relatedness between the outcome and also the independent variables. However, the accessories, there is no accessories in terms of this case. Means that the null is 1, and then this is not more than 1. This is not a risk to influence the outcome. Okay, this is a probability tables showing the tabulations of the data. So in a nutshell, so after you analyze all of this data, you can sort of have a clear understanding that the GSTM and GSTP is one of the factors that may influence the occurrence of these cases, okay, because we predict the cases based on this. And then you have the ability actually to report your findings straight away and giving the output accordingly. So before I end up my session over here, it is almost 40 minutes for me to discuss about these topics. Probably some of you might have a problem in understanding the conditions of our analysis, but it's okay because you can comment and then you can give feedbacks for this tutorial. And then I forgot to analyze the descriptive data. So you can just analyze descriptive and so on. And then you can insert everything inside except for a certain numerical data over here is not suitable. Same also goes to the gender and also type of cancer, because we are looking into the one medical conditions. And then make sure it is display frequency tables, and then just hit paste to generate your syntax. And then after the syntax has been generated, I'm going to do the same thing, but now I'm going to focus on the numerical data. So for the numerical data, I have to remove everything and insert only a few variables, which is age and also addictions. And I'm going to click the statistic radio button just to understand whether this data is normal or not normal, what is the minimum and maximum, what is the dispersion, and also what is the quartiles. Okay, and please make sure that you uncheck this box, because we do not need the display frequency for our descriptive statistic for numerical variables. All right, so everything is in place, and then you can click the Control R to generate those outputs. So those outputs actually here, you can see that the majority of the age is 55, and then you can see the standard error of skewness is 0.153, and then the skewness is actually 0.3. If you times 0.157 by 3, you will get something to do with 0.3 something. So it's approaching the value of the skewness or more than the skewness. So we can see that the age is considered to be normally tabulated in terms of the tabulations of normal in our data set. For the additions of years, actually looking into a little bit of skewed over here and there. All right, so this is our accumulative effects, not accumulative effect, I mean, this is our reported data by our respondents that we collected just now. And then the most important things that I'm going to share with you is actually all this table, because this is your demographic data that you should be presented it in the first place or in the first time of data analysis. All right, so I hope this video somehow giving you an idea about data analysis technique for the case and control study. I know that it's very hard to understand these discussions because you don't have the ability to have the data. You also have a very hard time to understand the codes over here, but actually the code is not being created, it's just being generated automatically by the SPSS. And then the making of the interpretation is kind of hectic a little bit because of your variables are having too many groups. So my suggestion is actually looking for the similarity of the groups first, and then you can just categorize it based on two major indicators. For example, you have five locality, and then you find out the prominent locality. Let's say the prominent locality will be the locality E, for example. Therefore, you can have the data based on E and non-E location. So it's much more easier to make a cross-tabulation and to produce the chi-square data analysis in terms of risk analysis. All right. So because this is formulations for the um, dependent variables, which is coded as 0 or 1. Therefore, we conclude that there is a significant relationship, your cases and control. I mean, in terms of influencing your cases, follows lah, which is I already explained before, is about the GSTT, GSTM, GSTT and also GSTM shows significant relationship with the IV and DV. And then last but not least is actually your addiction quantity in terms of years. So showing the significant lah. But of course, just now the data may suggest the directions of positive and negative. You might want to have a look back. All right. So sum up everything, guys. Thank you very much for your watching. Thank you very much for your time on watching this video, specifically talking about a case control study in terms of data analysis approach using SPSS. So hopefully, it's benefited to all of you, and see you again next time. Inshallah, we are going to learn more about logistic regression. Okay, see you again. Assalamualaikum and bye. Bye.